Welcome everyone to the second session of machine learning and implementing in natural language processing. So in the first session, we learned about what is uh, what is a chatbot. We saw how to design a chatbot, what are the key components, and we were looking at the open source library called RASA. So in the first session, we learned how to make our chatbot understand what we're talking about, and we added all the intents on what the chatbot should understand when we type something and how it interprets. We looked at we did a couple of exercises where we tried to play around with the policies and pipeline. And I think the one last piece that we were missing, I think we missed the last two slides because we ran out of time. We look at that. So just to refresh, what we did last time was we were talking about the pipelines, the different kind of pipelines we have, how they work, what is the purpose of each pipeline feature. So we were looking the last slide, which where we were was the intent uh, classification, and then how that works. So I gave the example of that a word can have different meanings depending on your domain. So if somebody says balance, it could mean a physical balance where you weigh things, but in terms of banking and finance domain, balance means your cash balance or your account balance. So the way it works is when you're defining the pipeline and it tries to create the vector count vector featureizer. So how does it actually understand that a certain group of word supposed to mean a certain thing? For example, if I say I give me the description of an apple, give me the description of a gala apple, give me the description of some other variety of apple. Each time you can frame a sentence differently. For example, instead of saying give me the feature, I can also say what are the key characteristics of a gala apple. So the way it groups all of these sentences into one group and understand that all of these different form of sentences mean the same thing is by creating a vector. So the way it does is, for example, if I say I need a hospital, it is going to break the word into break the sentence into different words, and is simply going to create a list, and then it's going to say depending on the engrams. So engram, if you remember, engram is where it tries to create a group of word from start value to end value. For example, if you specify if you remember the engram exercise where we try to change value from max engram to 4 and min to 1, and we flipped it that I don't want to create an engram of 4 words, create an engram of just 1 word each. And we saw that in some situation our confidence level when we said search find me a hospital, the moment it saw the word hospital, it was giving us 99% confidence. But when we slightly change the sentences, it was the confidence level was dropping. So in the engram, it tries to create, right? So when we say max engram of 3, so it creates 3 buckets. The engram once is going to say I need a hospital, it is going to give them a value how many times they occurred. Then it's going to move it to 2 bucket. I need a hospital into 2 word buckets. And then if it is defined all the way up to max engram 4, it is going to create a bucket of 4 word, and then it is going to give them values in there, like 1 0 0 1, meaning how many times a particular word has occurred. And the way how it is coming to 0 is it is going to create a list of all the words that are there in the sentences and is going to create a list. For example, I'm going to say I need a hospital. There is other word called I feel unwell, I need to go to the hospital. So the way it has done is it will say that these are all the values that can ever be present. And if feel is the second one and it's not present, it is going to mark it as 0. I is the first value, it is going to say yes, it is present. 0 is present. Now if I change this sentence to something like need a hospital, right? So I is dropped out and it says need a hospital, this value will become 0, and 1 2 3 values are present here, right? So it is going to say that, okay, whenever I see a sentence with I need a hospital or hospital need a hospital in any sort of combination, it is going to create the vector and going to say that, okay, the so far the sentences that I am aware of has 4 ones in it and in this sequence. Okay, and you can also try to convert it into bind it to give it a value. So 2 to the power 0, 2 to the power 1 into 0, and it is going to, you can create a number with it. So probably this will probably come to something like 64,000 some value. So this whole I need a hospital sentence will have a particular index, right? So then what happens is when it comes across a sentence where the word A is missing or I is missing, right? So in that case, say that, okay, I only have 3 ones, but this is the closest resemblance to a sentence which should have a intent and the action of finding a search facility, because it is going to give you that with, so say there are 4 one side. Assume if there are 4 ones and this exact sequence is present, then we're going to call it a 100% match. If one value is missing, then the match will be something like 75%. So that is why when you remember when we saw the logs, right, where, let me share my screen, when we try to run RASA shell, when we try a sentence, it gives a ranking of all the matches, right? So the way it is able to calculate 98%, 95% matches is by comparing the values, that how many values are one-on-one match at a certain location, or how many words are a match based on the number of words present in it that have been identified by the bot when it tried to train. So what's wrong with this? Oh, I think I was trying to do this.
So like the list of vocabulary in the slides are come from
These are
the NLU.md or NLU data that we set up.
Yep. So this is what we have provided some minimum, that these are the 2 sentences you might see, right? But customer, you cannot capture all the different variation that a customer may ask a question, right? So customer may simply say hospital question mark. Customer might simply say need a hospital, or they might say need hospital. You can add as many as you can think of, but there will always be situation where customer may ask in a different format. The intent of the question is same, but just the words are in around. So it could also be that they misspelled the word need with NED. In that case, this value will be marked as 0, but I'll still have like 3 out of 4 words which matches this exact same vector, right? So what we'll do is, if my Engram is from say 1 through 4, it'll say that in the bucket 4, I have 3 out of 4 match. When it tries to compare bucket of 3, so I need a hospital, in that case it'll say that again in bucket of 3 I have a 2 out of 3 match. So I and A will match, and then in need a hospital, A hospital match. So I'll have that. Then it will go down all the way to bucket 2, and will say I need a hospital. So out of this, will say that, okay, I have a match of exact 100% for a hospital, and then I have a 50% match on this. So that is how it comes up with the collective confidence level. So if I look at this now, RASA shell taking too long. Meanwhile, it starts up. Once it starts up, I wanted to show you the intent ranking and how those values change. And then I wanted to show you the what intents are present in our NLU.md file. Okay. So the last slide from the previous session is one other thing is that does the order matter for, and should I worry about the class imbalance, and what is class imbalance? When you have more than like one, when you have more training data for a particular intent, then that can introduce an imbalance. For example, if I have questions, so say for example, we are searching for 3 type of facility: a hospital, a nursing home, and say emergency room, right? So say these are the 3 type of facility we are searching, and I provide 20 different kind of utterances for hospital, only 3 or 4 type of utterances for the nursing home, again and again 3 and 4 type of utterances for emergency room, which means where is my code again? Which means if I open one of the data, so say I provided like a 1, 2, 3, 4, 5, 6 for intent grid. Imagine if I provide like 20 different utterances only, just and leave everything else 3 to 4, then yes, there will be an imbalance, and most of the confidence level will say that there's a high probability that the intent type is grid. Or if I provide a more utterances for a type hospital, that I need a hospital question mark, and I provide like 20 to 30 utterances for just for hospital and very few for home health agency, most of the time it is going to try to find the information on hospital and will give preference to those. So we need to be making sure that we are keeping a healthy balance between different type of searches. Otherwise you'll see that there's going to be an imbalance on that. Does the punctuation matters? Not really. Full stop, apostrophe, these are called the stop word, and they are dropped off. So when what happens is, and this is something you'll also see in when you try to search something on Google, right? Although they are like totally different entities and doing different thing, but if you see if you search in Google search or Bing, and you say for example, you try to look up who is Abraham Lincoln, it is going to drop all the unnecessary word as is, a, the, a, and all of that stuff will be dropped off. It simply identifies that, okay, you're trying to find somebody named Abraham Lincoln, and then it is going to try to pull all the information on that. If you try to write what was Abraham Lincoln known for, it'll again try to drop the preposition adverbs in there and simply focus on the keywords. So same applies in the chatbot as well. They're called stop words, and it's going to get dropped. And also there are settings in the RASA workshop, RASA bot, and many other chatbot framework like Dragonflow from Google, where they also identify singular and plural. For example, hospital versus hospitals, home agency versus home agencies, if it is singular plural. So those are already built in. It is able to figure out that hospital and hospitals are both the same thing, it's just a plural form. Other thing is intent classification entity extraction are case sensitive. By case sensitive, I mean, for example, if I write hey with a small h and hey with all caps, they are treated equally. So when the model is trying to build what are the known words, the first thing it does, it tries to convert everything into small caps. Every model, every paper you look at, that's the first thing they do. They try to change everything to small caps. So that does not matter whether it is in caps or small caps or a mix of all. It treats everything the same. What if you want to extract a entity from single word? So one word extractions are challenging. So and we saw that, right? When we just try to pass a value where it says what is a city, and we try to pass St. Louis, Missouri, we were seeing different result each time. And when as soon as we added a couple of example like Washington DC, Virginia, it started identifying correctly. So as long as you're giving an example that these are some of the sample values, it can come up with better prediction. Second way of doing is if it is a known set of values, for example, a list of zip code, a list of city, or a list of all the parks in United States. If you have that list and you load it from some database or a Excel sheet or CSV file or some form of API, then it can identify easily that these one words are known entity and they're already in my memory, and you can easily extract those values. But just by giving one or two random example, it'll become challenging. And those we'll see how in this second session, dialogue management, it handles those, how to handle such situations. Can I specify more than one values in classification model? Technically yes, but not going to gain any points. So when I say more than 1 in 10 classification models, I'm talking about the config.yaml, the pipelines. So if I continue to add all the known pipelines that I'm aware of, if I try to do that, it's not going to, you won't gain much after a certain point. You'll reach a curve and you won't get any extra points for confidence. Confidence level will be, for example, will get stuck in 96 and 97. So when I say more models here, for example, there are spacey tokenizer, right? There are many tokenizing libraries out there. There's a spacey tokenizer. You can add white space tokenizer. There are a few more tokenizer library you can add. So even if we add all of them together, in the end, after like a combination of one or two, it is not going to do anything different. You won't gain any extra points for that. So stick to one or two. That's my advice. No need to go beyond that. Okay. Typos, how do I deal with typos? So typos can't be avoided, and what you can either do is do a custom spell check in the pipeline. Second thing is you can actually go ahead and add a couple of typos which are possible. So one example is what you can do is you can connect it with a service like Google. Google has a way of fixing your misspelled words, right? So if I go and type something like if I go on Google here and I type misspell the word, it tries to correct me. Are you looking for XYZ word? For example, let's enter pet. Okay. So if you try and search like this, it is going to ask me that do you mean intercept? So you can have the same feature applicable and apply using code or using a service, and your chatbot can actually ask that do you mean to say you're looking for the word intercept? So one example is if I'm building a chatbot for car loan application, right, and customers ask that what is the car loan, and instead of loan he forgot to write the word o in the word loan, so it'll be car lan. You can correct that by calling the service and ask, did you mean car loan instead? And the user will see an option to select yes, no button and rephrase his or her query. Okay, so that's how you can go and avoid all that. Let me see. Oh, okay, so the service is up, and this is what I wanted to show you. If I say hospital, So these rankings which you're seeing here, right, 68%, 68%, this is how the values are being calculated across buckets. So you'll search across bucket that I got a word called hospital. So in the engram of 4, bucket of 4, it'll say that I have a 25% match. In the bucket of 1, it'll have a match of hospital, exact match, because it matches the spelling and everything. So based on that, it comes up with a collective confidence level of 68%. And also I'm using the Spacey library, which is a pre-designed library, so it's not going to perform well. Okay. Any question before we move on to the our session today on dialogue management? Okay. Okay, so coming to the next part. So now that we have trained our chatbot to understand what we are saying, now we need to help our chatbot respond back. How do we respond back? How do you train our how do you tell your chatbot to reply back with what you have asked? It understood when you say I need a hospital. It understands that you're looking for a search facility. Now it needs to respond back, right? So that is where the RASA core comes into picture. And as I explained in the beginning, that RASA has two pieces. One is core and one is NLU. So we looked at the NLU piece. Core is the main library, which actually does the decision making on maintaining how many history of sentences that it should keep in memory to create a context on what you asked. One example we talked about was what if we ask the chatbot, give me a suggestion on fictional book, and it comes back Harry Potter is a good book that you can read. And if you ask a follow-up question, is that fictional or non-fictional? So you haven't specified which book. So the core is the library which remember that you are talking about Harry Potter book, and the question of fiction or non-fiction applies to Harry Potter book. So those sort of stuff is maintained by core. So that's what we're going to look at, right? So today, as of today, most of the chatbots that are out there are state-based or rule-based, where you specify that you start with a state 0, where you start with hi, and then you ask a follow-up question that I am looking for a hospital, and the conversation goes in state 1. So at this state, chatbot has 2 options. If it has understood, it is going to reply you back. If not, it is going to ask you a follow-up question. Can you provide me the state or zip code? So that way it'll come to state 2. So state will keep changing. Now imagine there are more rules have to be added. For example, customer only provides 4-digit code, and it has forgotten to provide the 5th digit. Then it has to the chatbot has to check that and add a rule in there that you should. Oh, okay. Chatbot has to check that that if you are missing something, it has to add one more state, that customer may also provide a zip code which is less than 5 digits. So eventually your number of rules are going to increase as your chatbot model matures, and you will be ending up with lots of rules, and it will be difficult to comprehend when something goes wrong, right? So additionally, the rule-based chatbot behave very badly. Performance is really bad when you go off the topic. So if you call the call center and they say, hello, how are you? How is your day going? And the call center you called for is supposed to be fixing your network issue, and the user at the other end said, how's your day going? And you go on and on about how's your day going. And if it's a chatbot, it will not be able to respond back correctly. It won't be able to bring you back on track, right? So, or if everything is going fine and you have your information, you started at I need a hospital, and then it replies back that this is the address of the hospital, and then you keep asking, keep going off topic, like do you think I'll find a heavy traffic out there? I have been busy with traffic, and you go start chit chatting, the chatbot is going to fail completely. It's not going to help you with anything, right? So for example, if I'm asking where is the nearest Walmart, and you provide that 122 Walmart Drive, and it can also do things like it is going to close in 30 minutes. So if you want to add any additional smart feature where it can actually cater to your personal needs, those are the things that you can build with the contextual interpreted chatbots. So for example, here in using RASA or some other library, it can also find that, okay, you're looking for a Walmart, and then it will tell you that it's going to close. It can ask you that you don't have to go in then shop because that's going to take time. Do you want me to place an order online and you can just do a pickup? So those are the stuff that you can add in there, and your chatbot will be able to handle. Rule-based chatbot will not be able to do that for you.
So I'm kind of curious, that little chat thing. This looks like I would imagine this is like the future. Do you know any large like company or any large service that has achieved this type of like contextual chat?
So yeah, so you don't see it today as a like direct end-to-end service, but I'll give you example where I actually using it today, and you may not realize it. So if you have ever searched for directions on Google, right? For example, if I search for a direction on Google, say 1322 Google Crest Drive, okay, and I search this and I say give me and I say show me the direction from where, you will see that many time it is going to give you the option of this is the time it's going to take, and also here are the prices for Uber, Lyft, and all those, right? So those are way of doing what we are doing right here when it asks for Walmart, right? So if I say Wells Fargo, Huntersville Road, on the phone, I don't know if it's going to show here, but these are these are exactly the same thing which it is going to do. And if I go, I think, I don't know, it doesn't show option, but on your phone, if you're going to search at the bottom, you will be able to see that it shows Uber is going to take $20, Lyft is going to charge you so and so. So if you click on those, it'll automatically connect you with your account. So if today Walmart provides an API and says that you can connect to our API and place an order online, Google would probably go and add that feature as well. So right now it is also showing me that you can also find for groceries, gas station, and those. So you are already using many of these features today without realizing that they are already part of it, right? So if I don't know, it's on my phone, I'm able to see, it gives me an option that you have a Uber and all those other options. So it is there. There's one more small company that does that, but that is for medical equipment. I forgot the website I was looking at the other day. So what it does is you go on their website. I think it's on. There's one more example. There's a camel.com. This is one website which actually tracks your rate, which tracks your product, not product amount. Say you want to buy something on Amazon or eBay, and you want to keep a track on what is the best price and best time to buy. It keeps a track of those. And I think they might have changed the value, but camel come, and then it also tells you that what are the best places to buy a product. Another service which was recently launched, I think last year, is from Capital One, where what it does is it tells you that if you're buying something from a credit card, and if you link your credit card purchases with all the online thing which you're buying, it actually tells you that you just bought this item at so and so store, it is available at a cheaper price from some other store. Do you want us to automatically cancel your order and place it on that website? So it can do all that today, but not as a like a chatbot which we are talking about. I think this is the one. I think it's the website is probably down or something, but this site, if it whenever it comes up, you guys can check it out, and it provides the same feature that we are talking about here. Okay. So how is RASA core able to handle that? All these different features we talked about. If you're not building a rule base, how is it able to create so many things with just very little data? So if you actually see in our NLP.md, we don't have many examples available, right? There are very few examples where we are saying that here are just few sentences that customer might occur, and in exercise 6 we'll see that we're going to add like more than 30 or 40 example of each type of intent, right? But how is it able to handle different combination and think on its feet when customer asks something at random which it doesn't find as an exact match? So it uses machine learning to create sub stories. We'll see that how that works. And then it can handle the unexpected dialog flow and provide some complex logic and complex way of doing things. So one other thing which you're going to be seeing is how to integrate this with the third-party API to look up some of the addresses. Okay.
Sorry, Dinesh. I see remaining meeting time within 2 minutes. If this one cuts off, are we going to use the same one, or are we joining the other meeting link?
If it cuts off, we'll join the second meeting link which I've set up. It was supposed to be for like last time we started the first link continued for 2 hours. I don't know why I'm seeing this message again. So we'll see if it cuts off. You go on your meetup link, and there we have this second meeting invite as well.
Okay, thank you.
Okay. So let's go ahead and jump into our first exercise, session 2, exercise 1. So here we are going to look at the how we are going to train our chatbot to reply back to us. So the first thing we have is in the exercise 1 is to, let's go and explore this. So we saw that there's a NLP.md and these are the stories.md. So we briefly touched last time what is this file used for. So let's take a look at what has been created so far. Let me open the one. Okay. Okay, so let's look at this value here.